Hello. Uh, Sorry for running a bit late. Um, there was a little bit of a dinner making. There we go. Not really fiasco, but dinner making issue that occurred. Um, oh, that's pretty good. Um, so we're trying to help make some sog, which we hadn't made before, and came out all right, but was a little bit of a mess trying to get there. So I apologize. I am a little bit behind. Um, yeah. So, hello, Zephyr. Back again. Long story short, I'm trying to simultaneously eat and get everything set up. um, so, let's see. We need to get over to probably the this needs to be New Hampshire device. Please. Is it not spinning out for New Hampshire? Let's go. We won't go that route. We'll just go the slightly easier route. Let's see. It's actually kind of fun. Let's drop this down. So this guy, ooh, it's not appropriately set. Oh, maybe. Let's see. We switch that over to our like that. That's not what we want. We want this. Let's see. Let's see. It was this. Properties. Spider. Okay. Zoomed in about there. So yeah, I apologize as I'm just like got this going on in the background. I'm trying to just I might actually, for the purposes of entertainment, throw on my musical accompaniment to keep you guys going in the background, and I will be back in a little with my whole setup. Yeah, so let's bring out the electro swing goodies, and you guys can electro swing it up as I try and get all this set to go for the stream. All right, I'll see you in a bit. Okay, almost there. Just gonna give me a couple more minutes here and we'll be set to go. All right, let's just bring this down and then we go like that. And we can bring this back up because. Hey, how's it going? I'm hiding behind my desk a little bit. I'm gonna try and eat as we do this. I will mute it when I eat because this makes squishy sounds when I try to eat it, and I don't want to gross anyone out. So yeah. In the meantime, the goal is to continue our. So look, I got the console now up, so you can see the console. That's pretty nice, huh? Okay. Right. So the goal is to continue our efforts here. So one sec. Okay. So at the end of our last session, what were we doing? We were saying try to use W square root of Q times random. Okay. Thanks for the quote of John von Neumann. Famous, of course, for the von Neumann architecture of computers. That's still in use to this day. All right, all right, all right, all right, all right. So here's a thought. Let's see. Square root of q. Yeah, so here's what we're gonna do, right? We're gonna combine these. So what we're gonna do is we're gonna try using this as our function that we're trying to imitate. And we're gonna try using this version of W. Um, and then let's see. Okay, W Q, right? So Q is that initial thing. So we're saying the Q is the covariance of W naught. Sure. Okay, let's try. Let's see what happens, right? So as we continue along with our incrementing, we've got this, right? We don't need U. U is if you have the control function, right? That's your control inputs. We're not applying that. So what we are doing is taking yeah. Okay, right, we're iterating through right, because this counts by one because it's a Python data frame rather than a I'm sorry, it's a pandas data frame rather than a NumPy array. So if I go, for example, oh shoot, I have to generate this again. Man, I should have had this generated already. Apologize, this will take a hot second. So you already have. Oh, it's nice because I already have that. I don't need this. Hold on. Stop. Oh, stop. Die. Stop what you are doing. Okay, good. I already have how you have complete. All right, cool. Would like all this though. Okay. And I would like all of Schneer. But here's what I want to show you, right? So if you look at the annotation of this, so if I go, dot iloc 0. It should be, oh, they are different. So this are 0. All right, hold on. Oh, right, because it iterates through. All right. Yeah, because that's going to iterate, that's going to start at 2 because, no, we should iterate through 1. Okay. What on earth am I doing? All right, no, it's first day vector. So first day vector. That should be able to be 0, right? Yeah, that could be 0. What am I doing? There we go. Better. And now this should be 1, right? Um, oopsies. Shit. So if I go iloc 31. Okay, that is out of bounds. So this should be. I don't know why I had it in my head that that was going 1 to n. It says 0 to n minus 1. Um, Need to turn on that fan because it was getting warm in here with all the computer stuff. There we go. Windows open too. All right. Okay, so K is going from 1 to the end. So this is here we'll do like this. Day, right? So we're going that's the day that we're going. So if okay, I don't think we need that. What we need is um uh Kai K. I don't know if it'll let me use this. K minus. We'll just do K. All right. So Chi K equals I see indeed. That's why I did that. Okay. So we have to initialize it like this. Since this is separately initialized, we just have to call it out. So if day equals 1, right? Chi K is chi not um plus WK. So we said, I'm sorry, we say WK equals square root of Q. So that's the what's it called? The Cholsky of Q. Q minus times NP dot rand 144 comma 4. Let me make sure this is the right shape. No, what? It doesn't have a random number generator. That's ridiculous. Does he dot random dot rand? Huh? What cannot be interpreted as an integer? Yes, it is a module. Okay. Dot rand. So how do you do a numpy array of random values? Um, rand. Okay. Over 0, 1. Right. Of course. But I want of a specific shape. Oh, okay. It doesn't have the sub. It's just this doesn't have. Okay, so this should be. Oops, other way around. It's 4 by 144, I believe. So let's see. Will this work? I'm guessing it's not gonna work first time. No, Q. Oops. Q not's not defined. What? Okay. Let's try it again. Ooh, it did work. That's kind of shocking. Was not expecting that to work at first blush. Okay. So we in theory have something working here. Okay, and now plus WK. Okay. So now what we're going to do is we're going to set a W array. We're going to set, so this is going to be, we're keeping track of all the stuff that we're generating as we're going through so that we can look at later. Chi array, right? Sure, and then we'll build more of these as we need them. And now we're gonna say W array dot append W not chi array dot append chi not. Sure, so we're tacking these on to the beginning of that. And now we can also do X array dot append X not. That means we have to generate this X array. So X array equals that. All right. What else we have? We've got hat X array equals there. We got P array equals there. And then we got Q array. And then potentially R array, but we don't have an R naught, do we? Do we have an R naught generated in here? I don't know that we did. Q naught, so that is V, where the V vector is the error on which? The V is the error on the second part. So do we initialize the V naught? Phase measurement noise is the covariance of that. Let's see. When they do their thing here, what do they set? Do they set a V naught? QR is that. So X is initialize the estimate. Right, P naught. V, they have square root of R times random 2. Okay. Well, I guess there's no real R. I guess this is more R naught, huh? That's probably the best we got. So we could do R array equals there, right? And now we do X. Let me do hat is hat. Right. Just like this. Let's see, this is Q. And now they'll be singing it forever just because this is a song that never ends. All right. So what? Oh, should probably actually make that. There we go. Okay. Okay. Doop 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 doop. All right, now we need. This is time. So you K minus 1. So that's Q. So the only thing they have in the loop here that and prediction XM equals XE. What's XE? XE is the initial or initialize EKF. Simulation only. Oh, that's right. That's simulation. Okay. Initialize. Sure. F is the linear prediction. That's a different version. Okay, that's from a different version. That's fine. All right. We don't have to worry about that right now. Okay. Let's just continue with this version of this, right? So we're saying okay, so we're starting our prediction transformation. So we're saying we have WK is that. We're saying chi K is that. So that gives us this, right? Actually, will that work? Oh. Okay. The detector shape plus inhomogeneous has an inhomogeneous shape after 2 dimensions. Shoot. That's right. Let's see. WK. Right. We need it to be the vector multiplication, not just the times multiplication. Python vector multiplication. I forget what the command is for that. Vector multiplication. Crosshair. Now we need, I think, the dot product, right? So it should be dot. Hold on. Python. It should, yes, it should be dot. So it should be dot. Okay, shapes 1 1. Why is that? I said what? What? Why is what? Ow! Freaking because that's just that. Let's see. If I did W0 dot W0. Oh, hold on. NP dot transpose W0. NP dot array. NP dot array. We can do array math on this stuff. These should be matrices. These should not be single values. What's going on? I say, what's going on? Right? Because this should be a vector. Sure. Is it nice covariance matrices? The covariance matrices. I wonder if this. Oh, those. Okay, if that's that, right? Then that is there. Interesting, right? Because what is n? N is 600. All right, so that's all. Okay. That's a time step. So I don't want that. I want L. The size of the state vector is 4. Size of x naught is 4, but it's 4 in an array of 144. So that means because p naught, let's see. So p naught is 4 by 4. P naught is just right first day vector. Interesting. Uh, okay. So then if we did that, then what's p naught? is 144 by 144. 144 by 144. Um. That doesn't work. Man, we're making this infinitely harder on ourselves. So the problem is we're making each of these as an array, right? So each of the four here is an array rather than a single value. Let's see. Oh no, it's where state. So a Kalman filter where vector, right? But what if is this the same paper? Is that same paper? Okay. That's that stupid thing. So the question that's coming up is, what if the state is an array rather than a vector? That might not work in that case. Okay. Do I have that? No, I'm gonna have to. Man, so give me a second. Let me see if I can do this. I gotta do this. Sure. Let's do this. So here's what we're going to do. We're going to change things up a little. We're going to change things up a little because I think we are shooting ourselves in the foot by how we're trying to set this up. So right now, what's happening is that our state vector x isn't actually a state vector, it's an array. So instead of having this, what we're going to do is instead of having the state vector be the whole array over the, what the heck, over the course of the day. Well, that's interesting. Right? Wow, something's killing my, you. Wow, something's killing my display. Oh, that's cool. My display kept going black when I did that. Okay. Instead of having this, like, every time I'm clicking and holding, that's so weird. Instead of having this, what I'm going to do is we're going to take our low value, our high values, right? So it's going to be 1, 2, And then we're going to do our time of incline and time of decline. That'll be 4. That should do it. Yeah. That will be our state vector rather than our whole set of did our no, that's fine. So rather than our state vector being a whole array of values, we're going to have our state vector be this set of 4. Or what was happening before is my state vector was not even a whole an array of values 144 units long. It was an array of 4 vectors, each 144 entities long. And so we're going to instead go to an array of 4 values, a vector of 4 values rather than an array of 4 by 144. Doing so should get us back to what we need to be. Oh, hey, Bobo, I didn't notice you were in there. How's it going? I hope things are doing well. Sorry that I'm talking to myself in circles. I keep doing this. This is what happens when I try and do math and physics at night. My brain is already fried from working all day. And I'm like, hey, let's also do this. This seems like fun. Doot, doot, doot. Also, I would like to put Shadow up top. Thank you. Thank you. There we go. So I just need to get those 4 values that I'm going to use to actually make the state vector. And then we'll retry this. And I think everything will go a lot smoother. Actually, what we should do, if we were doing things correctly, I'm going to bump up my audio here a little bit. There we go. If we were doing things correctly, what we should do is we should first, if we're being smart, just instantiate this in Python, right? Because this is MATLAB code right now. So we should just do this in Python. Just run that conversion factor in Python. Give ourselves some confidence that we can do that. And then kind of move on from there. Because then we could just edit the sections of this instead. Huh. What's this? EKF and UKF. Let's see. Unset the Kalman filter. Oh, that's kind of cool. So it does out the steps in terms of the code. You want to try that? Let's try that. Let's try that. Let's try doing it the smart way. Come here, you. We're going to do a new one. All right. Now, this is just going to be ported over from this, right? So we're going to say alpha equals 1, beta equals 2, kappa equals 0, lambda underscore equals, because lambda is a function in Python, but it's not a function here in MATLAB, so you can use it in MATLAB and not in Python. Alpha, and now to do an exponent, you do that. times L plus kappa. That should be a K. And it's steady here, but L should be 4, I think, right? Yeah. Oh, here, let's just T equals 0.1 N equals 6. So what we're doing right now is we're just translating this. And then once we have it translated to Python, we'll try going through and slowly inserting our pieces into the code. N equals 600 and 1 equals 20. E1 equals 0 and 2 equals what on earth am I doing? E1 equals 0. And one E1 and 2 equals 0 and E2 equals 20. Right, so this is our time step total number of steps, and these are chords of sensors 1 and 2. All right, there's that, and now whoops, and spread this out. Now we get L equals 4, and now we've got alpha beta. There we go. Now we actually have an L. L plus kappa minus L. That's lambda. And again, this is, we've all done before for the other one, so this is just kind of recovering this. WM equals. Let's see, what do we have for WM here? WM. What's WM? WM. Ones. That, okay. I mean, we can do this, right? We can go, NP dot ones 2L plus 1 by 1. I think that needs to be like that, right? We can't do it while that's going. Okay. No, is that not how you set up array, or is there just it's missing a that's fine. Right? Invalid decimal literal. One. Yeah. 2 times help. That would help. There we go. I forgot you can't just. Yeah, you have to have the time symbol in there. That times 1 over times L plus lambda. Right. That's that. WC equals WM. Sure. WM. This is 0. So, something to note, MATLAB starts counting at 1 and Python starts counting at 0. Why MATLAB starts counting at 1, I have no idea. Every other coding language in the world, well, not every other. Most other, Julia doesn't. Most other coding languages start at 0, not 1. Why MATLAB had to be different? Actually, there's a reason why. Because MATLAB started as an array factoring or an array math package, right? As a language specifically to do array math. And array math usually starts counting at 1. So because of that, MATLAB to this day starts counting at 1, which if you're going to translate that over to Python, you have to remember that the 1 index in MATLAB is the 0 index in Python. Anyway, WN0 is lambda over lambda plus L. WC0 is this whole thing plus 1 minus alpha squared plus beta. Cool. And now we're doing define noise assumptions. Say Q equals and P dot was it? Is it still diag? Yeah, yep, it sure is. Diag. Yum 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 yum. 0, 0, 4, 4. And then Q for that. Sorry, this is all running in the background, running some data crunching in the background. So we're doing these little pop-ups here. Give me a second while this runs. Cool. All right. Q is that. R equals np dot diag 1, 1. And now x equals np dot zeros 4, n. Okay. Right, because that's a whole array of that. That's x x colon comma 0. So that's the first. This is x naught. So what they're doing is rather than setting x naught as a separate variable, they're just saying, I'm going to make this big ol' array of all the x's, and I'm just going to set the first column of it to be x naught equals 0, 0, 50, comma 50. Now if we look at x, all right. If we look at x, give me a second. Let me look at x. There's our 50-50. Beautiful, beautiful, beautiful. All right, that is doing exactly what we wanted to do. We know P naught is I. What is that command? Oh, it's the identity matrix. This numpy dot identity. Okay. I4. Okay. P naught is np dot identity 4. There should just be a 4x4 identity matrix. Beautiful, beautiful, beautiful. Now we say sim only w equals square root of q. So this is this Cholsky of q times np dot random dot rand 4 comma n. I think right. Is this not? What? That's right. So let's just see in square right. So square root of q, right? But square root of q is the Cholsky, right? Yeah. Should be the lower Cholsky. Observation. Okay. 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 Since the covariance matrix is diagonal, this. Stop doing that. The matrix square root is simply the diagonal matrix containing square roots of diagonals. Okay. So in this case, since it is a diagonal matrix, we can do this. just because it's a diagonal matrix. That's the only reason why I can do that. All right. And now, excuse me, conveniently R is also diagonal matrix. So we can go ahead and generate our error vector V. We can do now xt equals np dot zeros 4 comma n xt colon comma 0 equals 0 comma 0 comma 50 comma 50. Right, we're initializing that. Yt equals np dot zeros 2 comma n. All right. Let's initialize the state of the output vector for all k. Okay, so that's our array output vector array. Now for k in range 2 comma n plus 1. Oh, I'm sorry. 1 n plus 1. We go xt colon comma k equals 1. Hold on. 1 0. So that should just be what? That's just t. Hold on. If I do np dot identity floor times oh, I'm sorry. Plus hold on. This for so it's gonna be np dot array. Actually, here we can do this. Do it this way, right? So only now it's what 1 0 t 0. And then 0 1 0 t 0 1 0. Right, because this is the velocity piece. Okay, this is a time increment piece, right? It should be the dot product of this, right? np dot this with xt colon comma k minus 1. So the previous time step, right? We're dot producting that with the previous time step. Plus W colon comma K minus 1. So what does this look like if we do this? Is this not the right way to do that? There we go. So take that out, take that out. Again. Times random 0 for n square root of q, because q is that. Oh, that's a good point. Why is that length n? Why is that 4 by 400 or 4 by 600? That doesn't make any sense. Calculate the state trajectory of comparison. Also calculate the measurement vector. Random process noise. Oh, rand n. Right, because q, that should just be 4 by. Right, because if we did this, that should work. That works. Why is it by n? That just might be a quirk of the translation. So xt r. What? Oh wait, that should be 2 right now. 4 for that. Nah, it should be 2. That's why. I forgot. This is only a 2 by 2 matrix, so that makes a lot more sense. Okay. Is for one. One of size 4. Oh, wow, 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 wow. Q. Because Q doesn't change, right? So hold on. So W is a 4 by 4 array. Right? So W should be a 4 by 4 by n array. So this should happen. Squared Q. So those Q and R don't change, but Can I broadcast? Okay, okay. So now. np.shape is 4x1. Excuse me. And W is a 4x4. Should this just be... Maybe this is just piecewise multiplied. What happens if we just do it as piecewise multiplied instead of as dot product? If we just do this... No. Because that is a still 4x4. That's a 4x1. Should this be... Wait. Uh, is that times that? And W is a... W is 4x4. That's a 4. Wait, so why don't these work? They do work. Okay. Could not broadcast xk colon k. Oh, right. Because that needs to be... Right. That's got to be a 4x1, huh? Because that has to be a vector. The xk is a vector, not that. So, if I do this, this ends up as a 4x1, right? Yeah, that's correct. Uh, uh, that's also 4x1. That's why. I figured it out. NP dot dot. It's a dot product. That would be why that didn't make any sense. We have to use dot products appropriately. P dot dot. Because array math is silly. Okay, so that's that. And now YT colon comma K equals hold on, I gotta voop. I gotta voop. Oh, okay. Equals what? Square. Oh, okay. That is the velocity vector thing, right? So that's going to be very similar to this, but instead of this guy, it's going to be a 2x, right? Where it's where got that, comma that. And this is np dot square root x or xt 0 comma k minus n1 oops squared plus it's square root of that plus okay, so it's just a vector, right? So xt 1 comma k minus e1 squared, and then the square root of all of that, right? That's the top vector, and then the bottom vector is the same, but for n2 and e2, right? That's the y, the y coordinate, and then that. It's not a dot product. It's just that literally plus v colon comma k. I'm sorry, just plus v, right? So we can remove the dot product piece of it. They're not actually dot producting anything. Okay. We're getting there. We're getting there. Oh, that is a 2 by 2. What? What? I want that. Field elements must be 2 or 3. Got nope, nope, nope. No, I was right at least with that, right? So this should be okay, and then V should be that. What's this? What's this then? Field elements must be 2 or 3 tuples. Got what? Oh, I bet you I have a problem with my somewhere. No. Okay. Okay. np dot array comma okay, let's just try it with it might just be the brackets are causing problems. Let's just try it with this and see what that looks like. Oh God, what? Okay. Uh, There we go. Now we should be able to do this. There we go. Now we should be able to do this. Oh. Oh. Now we should be able to do this. Hey, it's alive. All right. And now. Whee. Okay. Okay, so we're gonna do. Yes, we're gonna save this as unscented copy. All right. All right, we're gonna stop there for now. It will probably be back online later for some gaming, potentially with someone else. In the meantime, sorry about this. I just decided to go back to first principles and start doing this. And then what we're gonna do is we're going to slowly change this once it's working and morph it into what we want to find. So. Thank you to everyone who showed up. Sorry again if this has been circling the drain when it comes to getting this Kalman filter to work. I think we started in a too complex way, and so going back to a simpler way to try and redo by copying this, and then reformulating this to be what we wanted to look at. Yeah. Sometimes you just have to go back to basics and be like, what the hell is actually going on? How did I overcomplicate everything? Yeah. So we'll do this again. Again, so sorry for going around in circles. We'll get there. I think it'll work. It'll work eventually. It's one of those things where you start a project, so you're like, this will take me 2 days. It's easy. 3 months later, what the? Anyway, yeah. So, thanks again for coming along on this very, very highly questionable journey where we will hopefully at the end up with something useful and new. Boy, oh boy. Thanks for sitting through this. Have a wonderful evening. Like I said, I might come back streaming later. If I do, feel free to hop in. There's a game that someone wants to try called... Yeah, right? It's like... you get to the point where you're like, all right, we're starting from scratch. Let's do this again. There's a game called Arena Breakout Infinite. I don't know. I think it's an extraction shooter. It was suggested to me. So either tonight, or if not tonight, then maybe tomorrow night, we'll do a little pew pew shooting in that game and take a look at it, see how it is, if we like it. I haven't really played extraction shooters before. Yeah, there's a specific subtype of first person shooter where you get gear and I don't know. Like you can lose your gear, right? Your enemy can shoot you and take all your gear and all that stuff. Anyway, regardless, feel free to join if you wish. If not, I hope you have a wonderful evening, and I will catch all of you guys either later tonight or tomorrow or next time we do math. So see you next time, man. Man, I have no idea why you keep coming back, but I'm so happy to see you. You put a smile on my face every time I see that you're sitting in chat listening to my insanity. Python's always a battle. Yeah. Anyway, well, together we'll eventually learn something. I don't know what it is, but we'll learn something. You guys have a great one. I will be back. I'll post more on the Discord as far as next time I'm going to do another math stream. It'll probably be a few days, but we'll get there eventually. So thanks again for sticking through it, and we'll see you